Hello, in my last video I showed the design of this workflow, and in this video I'm gonna explain a little bit change of the workflow. As you can see, in the last video the workflow output basically output the model prediction, and in this one I modified that a little bit so that I have another P workflow which take the output of different models and then choose the best model in terms of the evaluation summary. And also I make another change for the model P workflows. So basically for the testing, we basically doing a cross validation for the model performance evaluation, and then the model evaluation output was put into this model selection P workflow, and this P workflow will choose the best model based on the summary parameter we have. So I will show what I mean. As you can see, I just finished one run of the workflow I just showed, and over here, as we can see, we have the output of this workflow over here. So this is basically a evaluation cross validation evaluation summary. So the correlation coefficient is basically the correlation coefficient value for the predict variable, predict value, and the true value which we have in the test set. As you can see, we have 300 instances in the test set, and this is the mean absolute error. So meaning we calculate the sum of the absolute error for all the prediction and the truth in this testing set, and we do a mean. Similarly, this is a square root of the mean squared error. So we do a square of the error first, and then do a mean, and then do a square root. And those two, they are relevantly absolute value is basically we do a prediction value and the actual value. We sum the absolute, and also we divide them by each of the actual value to minus the average of the actual value. And similarly for the last one, root relevant square error, which is do a square root of the square sum of the prediction and the actual, and use that divide the actual value minus the average value. So basically these four errors are related. Basically tells us how accurate that model is, and this correlation coefficient tells us the coefficient how strong that is of the prediction value and the actual value. Actually, for regression model, another common factor we use to evaluate the model is so-called R-square. It's called the coefficient of determination, which is actually the square of this coefficient, correlation coefficient. This basically tells us how well the model, in terms of how much variance of the data set can be predicted or can be explained by our model. So say the square root of this is around let me see how much that is. So the square root of this is almost 54.8%. So that means for our test set, more than half of the instance can be covered by or explained by our model. So as we can see over here, I did a little bit explanation of the summary here, and as we can see, we have two output because we use two model, right? So this is the first model we have here. Remember, this is 0.7, and we have another model which is here. So let me see. Yep. So one is 0.706, the other is 0.7436. So apparently this one performs better in terms of the explanation of the variables. So as we can see here is the output. The output basically right now I just output the whole path of the output file, so that it can tell us, okay, this is the model we have. We choose this one because it performs better.